Hello, welcome back to my YouTube channel, guys. Today's question is minimum penalty for a shop. Now this question for the description is says we are given the customer visit log for a shop represented by a zero index string, customer consisting only characters n and y. So the n character represents zero customer visited and y means one customer visited. So now we going to, you can read the description and understand by yourself. I'm going to only provide you the code for that. So the first approach will be our brute force approach, and this approach will be we are going to try to close the shop at every possible r j from 0 to n, simulate the penalty. And this approach going to cost us O of n square because it is brute force, but for the space it is going to cost us big O of 1. Now for the better approach, we are going to use prefix, prefix and postfix, and it is going to cost the big O of n for the time complexity, and for the space as it is going to store prefix and postfix, so also big O of n. And the most optimal approach is going to be our one pass approach, and that will be going to cost the time complexity of big O of, let me write it, one pass, and it is going to cost the big O of n, and for the space it is going to cost us big O of 1 because we are not using any postfix prefix or any extra arrays and all. So n is equal to length of customer. It is just simple and good habit to do that. Now what we're going to do, we define our minimum penalty as infinite numbers, we're taking a very big value for that. And now we define our best r as 0 for initial. For j in range n plus 1, and the penalty we defined as 0 for I in range. For I in range, we are going in length of nums, means, oh sorry, length of customers. Now we check if our I is less than j, then what we do here is we are going to check if customers of I is equal to our n, then we increase our penalty by 1. In the else case, we check if our customers of I is going to equal to the y, then our penalty again increases by 1. Now we check if our penalty is less than our minimum penalty. If our minimum penalty is greater than penalty, right, then minimum penalty is going to be penalty, and the best r is going to be j. Now we return simply our best r. Let's run the code. And you can see every case are getting accepted. Let's submit that. Maybe this code will not submit because it's time complexity, or it will provide very long time complexity, which is not good for this question. We have better approach for this question, so we are going to implement that. See, time limit exceeded. Now we are going with our better approach, which is postfix and prefix. Now in that approach, we are going to define again n as length of customers, and our postfix prefix is equal to 0 into n plus 1. Same for the same for the postfix. Now what we do, we are going to for I in range in the from 1 to n plus 1 for the prefix. Now we defined our prefix of I is going to be equal prefix of I minus 1. Now we're going to check if our customers of I minus 1 is equal to our n, then we simply increment our prefix by 1. Now we are going with for I in range n minus 1. This is for the postfix minus 1 because it will start from the end in the reverse order, so that's that. Now postfix of I is going to equal postfix of I plus 1 because I plus 1, not I minus 1. Now if our customers of I is equal to our y, means yes, then our postfix will increase by 1. Now what we do, we are going to define our minimum penalty as last we did, float infinite like a big number, and define our index as 0 for initial. Now for I in range n plus 1, not 1, n plus 1. Now we check if not, we are going to define our penalty for the starter. What is our penalty? Penalty is going to be prefix of I plus postfix of I, and then we check if our penalty is less than our minimum penalty, then we make our minimum penalty as penalty, right? Spelling is right. Then we define our index as I. Now we simply return our index. Let's hope this code works. We are getting error, sorry guys, because we have to increment our prefix of I and postfix of I, not prefix and postfix. Let's run the code, and we are, oh sorry, this is our typo. Let's again run the code, and yes, see, every cases are working correctly, and this is my entire code. Now let's submit the code and see, it is getting accepted and it is getting good complexity. The complexity is big O of n, and the space complexity is big O of n also, so not getting very good. We can do better than that. Now let's remove that and write our final, the most optimal solution. Now our most optimal solution is going to be our easier solution also. Now we're going to check if our y not in our customers, then we simply return 0. Okay, and we're going to check for same as n. If our n not in customers, then we return length of customer, right? Now what we do, we are going to define our profit as 0, maximum profit as again 0, and the best close time as 0. Now what we do for I and C, I define index and C define customer, going to enumerate in our customers. Now we going to increment our profit by 1 if our customer, if our C is equal to our Y, else we return -1. Now we again check if our profit is greater than our max profit, then our max profit is going to be our profit, and the best close time is going to be equal our I plus 1, and now we simply return our best close time. Let's run the code. See, this is very small and simple code, you can remember it easily, and this is the most optimal solution for this question. Now let's run the code and see, it is getting accepted, and we are getting better space complexity and time complexity also, because it is one pass solution. So if you like the video, you can subscribe my channel, comment and like, and share the video as much as you can. So thank you.